meet the third central moment, that being skew. And skew, roughly speaking, deals with asymmetry. We're going to see in just a moment that that's not technically true. What's really going on is we're asking about large deviations that are to the right of the mean and asked to what extent, either in quantity or severity, are they offset by deviations to the left of the mean within any given distribution. I mean, that sounds a lot like asymmetry, and from a practical standpoint, it kind of is. We found a fun visual that we wanted to share with you, and this is kind of the elephant distribution. The area under the curve is 1. We found this on Stack Overflow, and it is clearly an asymmetric distribution, but its skew is 0. Now, most people, when they hear a skew of 0, they think of asymmetry, and it's one of these like logical, you can go in the one direction but not the other. If a distribution is symmetric, its skew is 0, but if a skew is 0, you can't immediately infer that you're dealing with asymmetry, which is what this kind of elephant distribution is showing you. Your distributions, kind of your Hall of Fame distributions like the geometric or Poisson or continuous, they'll all have a formula for skew. Like the continuous uniform distribution has 0 skew. The Poisson distribution has skew of 1 over rad lambda, right? So that's kind of nice. But you can also work with skew directly in your data. And we can go back to our S&P 500 data, daily performance, and we see that there are these spikes. And as it turns out, the kind of sudden down days are more than offset the big up days. As it turns out in the stock market, it's when not that much is going on where investors make all of their money. Of course, there are big good days, but if investors could get rid of all the big good days in exchange for getting rid of all the big bad days, they would, or at least they should. And skew is really what's going on there as to why typically things are not as good. And we find if we just go in and calculate, I'll show you what I did here. I just said equals skew of column H, where H is my daily performance. And I come out with negative 0.29. Now, I do want to make a point here is that both skew and kurtosis, the third and fourth moments, they're unitless. So our daily performance is in percentage return. Like I had a 0.71% return on the first day of this investment period that I'm investigating. And when you look at the first 2 moments, they are in percent returns. It's like 0.039 per day, 1.18% is the standard deviation. But I don't have percentages for either the third or the fourth moment. Context matters here. And what you'll generally find is that if we're speaking in absolute value terms, if we have a skew between 0 and call it a half, that's kind of modest to moderate skew. If you've got skew of, call it a half to 1, that's more notable. And if you have skew bigger than 1 or even a lot bigger than 1, then skew really matters. It's quite important. When we were thinking about that first 4 moments sheet, we see, like, say, the normal distribution is perfectly bell-shaped. It is symmetric, and therefore it has 0 skew. When we think about something like the exponential distribution, well, there's just like this big fat right tail, right? And that's got lots of skew. That's a very high skew number. When we stop and think about what we know about the exponential distribution, it's very asymmetric, and we do have skew going in one direction. Notice that skew is positive too, and we have a very long right tail. If you're an investor, your average daily return, that's your first moment. Your second moment is kind of like the initial way that you think about risk is standard deviation. But when you're looking at a negative skew of negative 0.29, what that's telling you is that, I want to go in with eyes open. There's a meaningful amount or degree to which the really bad days are going to be worse than the really good days are good. I just want to throw one more thing at you, and I took the liberty of putting together Google weekly performance data. So that's Google stock performance. And this is not apples to apples. First of all, we're looking at one company, Google, versus the entire stock market. We're looking looking at weekly data as opposed to daily data. And we're not really looking at the same time periods because the stock market that I put together for you started in January of 1993. Google didn't even go public until I think like 2004, 2006, something like that. So I want to point out the skew values is whereas we had negative daily skew for the S&P 500, we have this positive weekly skew for Google stock. And that makes all kinds of good sense because, well, over the period since it's gone public, Google has risen through the ranks to be, I think in August of 2024, like one of the top 5 most valuable companies in the S&P. So, you got to be doing a lot of things well. You got to be doing a lot of things right to move up to like, say, the top 5 out of the top 500 stocks. Probably a little bit of positive skew helped make that a reality. So we get some kind of a nice insight from looking at the skew figure once again, the third moment of our distribution, this time applied to Google weekly price analysis.